So 1965, 75, you moved on to Dryden.
Right, but I did, before that though, I transferred from about 1968 through 75. I worked at Vertical Short Takeoff and Landing.
Oh yeah.
And I could give you some things that we did there. What we were looking at there in those early days is this concept called a jet flap, where you would have multiple engines on a wing and then have the exhaust of the engines go down on the wing, where you'd have essentially a flap, which would give you a tremendous amount of lift for takeoff, see? And so we did a lot of wind tunnel tests with these little 5.5-inch engines, like 4 of them, along a semi-span wing in a full-scale wind tunnel. The wind tunnel was the largest in the world, 40 by 80 feet, with a test section. And we could test, we have tested full-scale airplanes in there, but we were just looking at vertical short takeoff and landing tests. And my job at the time was to model the flow mathematically, with the program, and also run the test. Some people would be the test engineers, would do the test, get the data, and we would look and see if we could model this and see if we could predict the amount of lift coefficients you get as a result of this jet flap.
Grumman and some of these big
Oh yeah,
companies, and then
all our research that we did was shared with the aerospace industry. In other words, what we tried to do is to do high risk research that maybe they didn't want to put their dollars in, and then we would try to leverage that research by sharing with the U.S. industry in areas that would help or complement some developments that they were doing, because at that time there was a major push on vertical short takeoff and landing for military, not only civil,
Right.
but also military reasons. Okay, so that was a big emphasis. The other thing that was the other major issue that we were testing between 1968 and 75 was to reduce noise of aircraft engines. So we actually did some analytical work to look at different nacelle shapes and splitters inside nacelles to reduce aircraft noise. Because at the time, there was a lot of concern in different airports regarding, the acoustic level, the dB level next to airports. And so we did a lot of research. It was called quiet aircraft engine technology that we were doing research. And we actually tested these engines and measured the different acoustic performance of these in the early 70s. At the 40 by 80 wind tunnel at Lewis Research Center. So that was my other experience as a test engineer, and also some analytical work at Lewis Research Center in the 70s.